Today we're starting 3.5, finding real roots of polynomial equations. First thing I want to look at is solving the polynomial equation by factoring 4x to the 6th plus 4x to the 5th minus 24x to the 4th. By applying things we've used in the past, I want to see if you can factor this. Coming around and seeing what we've been doing, most of you looked at this and saw they have one in common. 4x to the 4th. This one has 6, this one has 5, this one has 4. So that's the most they all share is x to the 4th. If I factor out an x to the 4th out of a 4x to the 6th, x squared. Factor 4x to the 4th out of a 4x to the 5th, you're left with x. And the last one, if you factor out a 4x to the 4th out of a negative 24x to the 4th, negative 6. It's quadratic. We know how to solve a quadratic. First thing we'll try to do is factor. If you can't factor, that's when you'd complete the square quadratic formula the other ways. How can I get an x squared? X and x. What's this tell me? Different signs. One's plus, one's negative. Two numbers that multiply to get me 6, but subtract get me 1. 3 and 2. 3 is the positive, 2 is the negative. Now solving the 0 for 0. This one here, I get a 0 of 2. This one here, I get a 0 of negative 3. And this one here, I get a 0 of 0. To check your work, you can use a calculator.
What did you do on that last part? It's 2, negative 3, and 0.
Take the opposite of what's inside the parentheses. So if it says x minus, change to a plus. The number out front or the variable out front will always be 0 as long as there is a variable. If I just took out a 4, 4 is just a number. It's not a 0. If I look in the calculator, I type this in the y equals. All right, typed it in there. Now I can graph it. Let's see what happens. If I look at the graph, comes down, hits here, goes down, comes back up, hits here, goes back down, goes back up. So I have 0 at 1, 2, negative 3, 0, and 2. Graphs aren't always the best things to see them, so we can look at the tables also. Second graph takes you to the table. We have a 0 here at negative 3, a 0 here at 0, and a 0 here at 2. It's a way to check our answers. Try this one. This one's a little bit different. Got to rearrange it first. X to the 4th minus 26x squared plus 25 equals 0. Why does it look different? Okay, they all don't have anything in common. What's giving you a hard time right now? X to the 4th. I need to break up an x to the 4th somehow to get x squareds. Not square root. X squared and x squared. Normally we would have x squared minus 26x plus 25. You put x and x, right? You split this in half to get single x's. Here I have x to the 4th and I need x squareds. So x squared. What's this tell me? Same, and they both have to be negative. Two numbers that multiply to get me 25, but add to get me 26. 25 and 1. 25 times 1. Now, what this means here for my zeros, Normally on this one where it'd be x minus 25 and x minus 1, you'd say your zeros are 25 and 1. This has an x squared. This would mean x squared equals 25, x squared equals 1. How do I find out what x is? Square root. Take the square root. When I take the square root of an x equals plus or minus 5. X equals plus or minus 1. Those are my zeros here. If I graph it, here's the graph. Crosses at -5, goes down, crosses at -1, comes back down here, crosses at 1, and crosses at 5. You can see it by the graph. You can also see it by the chart. Try this one. All right, for this problem, what do we have in common? 2x to the fourth. If I factor out a 2x to the fourth, I'm left with x squared minus 5x minus 6. 2x to the fourth, x different, so it's plus minus. Two numbers that multiply to get you 6, but subtract to get you 5. 6 and 5. Or sorry, 6 and 1, subtract get me 5. Some of you had 3 and 2. 3 and 2 does get me 6, but it only subtracts to get a 1. So I'm going to put minus 6, 1's a positive. My zeros, 6, -1, 0. Those are your 3 zeros. It's always the opposite of what's in the parentheses. Now, these points, there's something else we can tell from them. We're going to talk about something called multiplicity. Multiplicity of a root is the number of times that x minus r is a factor of a function. If it has even multiplicity, the graph touches but does not cross. If it's odd, it goes across it. In this example up here, 3x to the fifth plus 18x to the fourth plus 27x cubed. It only has 0 and -3. We can tell right now that 3 times x happens to be 0. I know this doesn't make sense right now. I'm going to flip back in a couple examples and look. So if we flip back to the last problem here, I have zeros of 6, -1, and 0. -6 happens once. Sorry, 6 happens once. -1 happens once. This 0 right here just happens to have a multiplicity of 4. Now, when I write multiplicity, I just write in parentheses x4 times 4. You can write multiplicity of 4. You can abbreviate your own way. There's a way I know it's equal to 4. If I have x to the fourth, that means here I'm going to have 4 zeros. This one here, this one happens twice, or once, twice, once, twice. There's no repeats. This one does not have multiplicity. The first one we did. Happens once, happens once. This one's going to happen 4 times. You can also tell how many it's going to be. 1, 0, 2, 0, there's 4 here. So what do I have in total? 1 here, 4 here. 6. What can you tell me?
That their multiplicity is
Not the multiplicity. The number of zeros is going to match the degree of the function. What's my degree? 4. The degree is 4. I have 1, 2, 3, 4 zeros. The degree is 6. 1, 2, 4 here, so I have a total of 6. This one here has to have a total of 5 zeros. So if this one happened 3 times, how many times does negative 3 occur then? Twice, because it has to add up to that exponent. When the multiplicity is even, this is what the graph is doing. It's going up, touching, coming back down. If the multiplicity is odd, it's going to go through that point. So here I had multiplicity of 4. I know at 1 or at 0, the graph's just going to be a hump right there. Let's look at this one now. Coming around, I was seeing what people were trying. A lot of you are trying to break it apart and use factor by grouping. X squared, I'm left with x plus 6. Take out a 4, I'm left with 3x plus 2. I have a problem. They don't match up. This didn't work. Sometimes you get stuck. What I'm going to show you today, the book's going to show it a different way. I'm going to show you how to use technology if you get stuck. You might not know how to factor something. Right now, we're pretty good with quadratics. First thing you have to do, put it into y equals. X cubed plus 6x squared plus 12x plus 8. Now I could go and look at the graph, but the table is what's going to help me the most. So I'm going to go second graph. I'm looking at the table and I need to find a 0. These just keep getting larger and larger. I'm going to go the other way. I don't put equal 0. It hits 0 at negative 2. So I'm going to take negative 2 and use synthetic division to help me out. The 0 is negative 2. If I were to write it in parentheses, it'd be x plus 2. All right? So 1, 6, 12, 8. So using synthetic division, bring the 1 down. Negative 2 times 1, negative 2. 6, negative 2, 4. Negative 2 times the 4, negative 8. 12 minus 8 is 4. Negative 2 times 4, negative 8. I'm left with 0. If I don't get a 0, I had to have done something wrong because the calculator told us it was 0. So right now I know this. Negative 2, or x plus 2, 4x, x squared. I took and I factored out the x squared, or x plus 2. And I'm left with x squared plus 4x plus 4. And we're going to try to factor this. How do I get an x squared? X and x. The plus tells me they're going to be the same. They both have to be positive. What times what's 4 but adds to get 4? 2. So this zero's negative 2. This one's negative 2. This one's negative 2. My answer is negative 2 with a multiplicity of 3. Why is it a multiplicity of 3? It happened 3 times. I also know there's only 3 because of this. X cubed tells me I need 3 zeros. If you don't get 3 zeros, you know something's wrong. Now, some of you are going to think, well, I'll just use the calculator, and I'll look at the table, get my zeros, and there's all my answers. Calculator can't tell you multiplicity. Sometimes it is, sometimes it isn't. The calculator doesn't say which one's which. On this one, I mean, you can almost tell it's negative 2, that's cubed, it will probably been times 3. But sometimes you have a graph, say it goes like this, and eventually over time it comes back down. You weren't sure if there's something else there. This one we knew it wasn't because there's cubed. I have x to the 4th plus 8x cubed plus 18x squared minus 27. If I try to factor by grouping, I take out an x cubed, I'm left with x plus 8. There's no way I can be left an 8 from a 27. So I know factor by grouping doesn't work. Which calculator do you have? You have the black one? Black one, it just does a caret. The yellow one, that's where it's going to make it different. All right, when I graph, I'm going to go right to the table. Second graph. I see I have a 0 here at 1. And if you look, there's one at negative 3. So I'm going to pick the 1. I'm going to put the 1 in here. I have 1, 8, 18, 0, negative 27. Why did I put the 0 in this one? Filler. There's no x here. All right. Bring down the 1. 1 times 1, 1. 9. 1 times 9 is 9. 18 plus 9, 27. 27. 27. 27. Because I need to filler because there's no x. So I know right now I have x minus 1, x cubed plus 9x squared plus 27x plus 27. I'm not sure how to factor from this. I don't know how to factor an x cubed plus 9x squared. Now I got so far, I'm going to use another one of the zeros. So I'm going to use the other one of negative 3. And I'm going to use this one here. Don't go up and start over again. Because if you do synthetic again, you're going to end up with 2 problems started that you can't get any further. Take 1 0, go so far. Can't go any further. I have 1, 9, 27, 27. 3, negative 9, 0, 0. Wait. I was off the line. Off the line, we'll start over again. 1, negative 3, 6, negative 18, 9, negative 27. I would have caught myself when that wouldn't have been a 0. So I have x minus 1 from the first one, x plus 3 from this one, x squared plus 6x plus 9. I have a quadratic. I know how to solve this one. X minus 1, unless you want to do long division, x plus 3. To get an x squared, x times x. Both have to be positive. It is 3 here.
Oh, I told you.
So I have a 0 of -1, or sorry, +1, making too many mistakes, and -3. The -3 has a multiplicity of 3. That's my answer.